Let n be a positive integer. A Japanese triangle consists of circles arranged in an equilateral triangular shape, such that for each I from 1 to n, the ith row contains exactly I circles, exactly one of which is colored red. A ninja path in a Japanese triangle is a sequence of n circles obtained by starting in the top row, then repeatedly going from a circle to one of the two circles immediately below it, and finishing in the bottom row. Here is an example of a Japanese triangle with n not equals 6, along with a ninja path in that triangle containing two red circles. In terms of n, find the greatest k, such that in each Japanese triangle there is a ninja path containing at least k red circles. Now let's look at the solution to this problem asked in International Mathematical Olympiad 2023. We have a circle pyramid with red circles in each row. A ninja path is drawn and it has a few red circles. Now in order to get a K such that each Japanese triangle has a ninja path with at least K red circles, we want to check for the worst Japanese triangle or worst case and get the value of K in that case, so that any Japanese triangle which is not the worst case will have at least K red circles in some ninja path. Notice these parallel aligned circles. It's impossible to go from some circle in this line to a circle in this line in a row below the circle considered in previous line. For instance, it's not possible to go from this circle to this circle. So if we make these two circles red, it's impossible to obtain both in a ninja path. And we can continue like this for the rest of the rows. Now, considering the worst case scenario, we draw the red circles like this. Since the sequence ends here, we start over from the first circle in next row. Now we can consider the case when n is 10. For a larger n like 10, we color the circles like this. Now we have a few sets of circles in parallel lines, let's call them parallel circles, and in each such line it's possible to cover at most one circle in a ninja path since no two circles can be obtained from the same line. Now we want to count how many such parallel lines of circles or parallel circles will be there for a given n, and since exactly one circle can be in a ninja path from the same parallel circles, we count the number of such parallel circle lines, and this will be our answer. Now we look at those rows in which the first circle is red, since it marks the start of a parallel circle line. The first such row from the bottom has 10 circles. The next row where first circle is red has 5 circles, which is floor of 10 divided by 2, and this has only 2 circles, which is floor of 5 divided by 2. It would make for an interesting exercise to prove that in each such subsequent line the count of all circles gets floor of half of number of circles in previous line. Now the number of such parallel circle lines will be the number of times we can divide by 2, the number of circles in last row, that is n. This is what is equal to log of n to the base, 2 plus 1, and adding 1 because of the red circle in top row.